Alright, in this video we'll be covering this challenging integral secant x, so pause the video now to solve this on your own. Alright, so to solve this, my first step is I will consider secant x as 1 divided by cosine x. So now what I will do is I will multiply the numerator and denominator by cosine x. This will allow me to use the Pythagorean identity later. So in the numerator, we will have cosine x. And in the denominator, we will have cosine x times cosine x, or cosine squared x dx. We now need to consider the Pythagorean identity, which is sine squared x plus cosine squared x equals 1. So subtracting sine squared x from both sides isolates for cosine squared x, giving us cosine squared x equals 1 minus sine squared x. Returning to our integral, we will substitute this in. So cosine squared x will be replaced by 1 minus sine squared x. So now here we need to spot a u substitution. So when we look at this, if we let u equal to sine x, when we take the derivative on both sides, we end up with du equals the derivative of sine x, which is going to be cosine x, and then we have our dx. So now when we isolate for dx, we get dx equals du divided by cosine x. So this will allow us to cancel out the cosine x and just leave us with 1 minus sine squared x. Since u equals sine x, that just gives us 1 minus u squared. So now we simply have this relatively simple integral here. So notice this is a difference of squares, so we can rewrite this. This will become 1 minus u, then 1 plus u. Alright, so now we need to use partial fraction decomposition, so I'll set this up here. So since we just have du, we have 1 divided by 1 minus u times 1 plus u equals a divided by 1 minus u plus b divided by 1 plus u. Multiplied by 1 minus u times 1 plus u on both sides gives us 1 equals a times 1 plus u. The 1 minus u is canceled out. And likewise for b, the 1 plus u is canceled, so we just have 1 minus u. So distributing this, we have 1 equals a plus b plus, factor out u, we have a minus b. So this lets us set the coefficients equal to each other, so we set up this system of equations. So since we know the u term, this is really 0u plus 1. So we know the u term is equal to 0, so a minus b must be equal to 0. And finally, since we know the constant term is 1, a plus b equals 0. Sorry, excuse me, 1. So here we determine a is equal to b by adding b to both sides. And here we have a plus b equals 1. So since a equals b, this means this is 2a equals 1. So a equals 1/2. But since a equals b, this means a equals b equals 1/2. Coming back here, we can split this integral up. So I'm going to move our 1/2 in a and b outside the integral, so that will give us 1/2 times the integral of du divided by 1 minus u plus 1/2 du 1 plus u. Alright, so now when we look at this, this is a relatively simple integral. This is the form of the natural log. So if we were to do another substitution here, the new du, so, well, we already have u, but the new du would be negative since this is 1 minus u, which becomes a minus when you take the derivative. So we actually have to flip the sign here. So we have negative 1/2. And in the natural log, you would have the denominator. So we have 1 minus u. And however, here, when we look at the denominator, we have a positive term for u. So we don't have to change the sign. So we just have natural log 1 plus u. Alright, so now we need to remember our natural log properties. So since this is a minus, this can be moved inside as the denominator. So we simply have 1/2 natural log of 1 plus u divided by 1 minus u. But now we need to remove our u, replace it with the original value, which was sine x. So we have 1 plus sine x divided by 1 minus sine x. And don't forget our plus c. So that is the solution for this integral. If you enjoyed this video, make sure to subscribe to the channel to see more content.